Never miss the latest videos from the people who help you play better golf. Hit subscribe here.
All right, hey, I'm here with Tom, who's the VP of R&D for Cobra. Tom, thanks for hanging out and talking some golf and some driver design. I've got some hopefully compelling questions, but you've got 3 cool drivers here, and I've tested them all on our CG and MOI machines to measure them, because I think that's the best representation of everything except for like total ball speed. Is obviously a guess without doing some robot testing to see what goes into the actual face itself. But so far I am extremely, not necessarily surprised based on previous years, but I'm pretty excited about these because you've done some things that I think are very different than other OEMs. So the first one I've got here is the LTDx, and I forgot to say congratulations. Nice job. You did great.
All right, thank you.
So I've got the first one here is the X, the LTDx. This one I think is probably going to be our biggest seller based on the performance that I've tested here, and you can tell me if I'm right or wrong on that one. But you did an awesome job with this one. The CG is right in the middle of the face. I rarely find OEMs that do that, so I've got to ask your secret about that in a second. But the CG on this is in the middle. The MOI is extremely high, so 5178 grams per centimeter squared. This should be a fairway finder if there ever was one, and getting the straightest ball flight. So maybe, I don't know if there's something interesting you want to tell me about this, but how do you get the CG right in the middle of the face, and maybe tell your competitors so that they'll do it better?
Well, part of that is really over the years of learning a number of things. And this driver goes a little bit back into the LTD of 2016, which was also a 0 CGNA driver. We know that if you have the CG right in the middle of the face, most people tend to hit it when you're going for distance slightly above the face, and therefore you get a little gear effect shot. So that's a key thing. If you can get that CG down low, you get the best performance and the best ball flight. We know that we have a speed limit like we just mentioned, but we want the best launch conditions to maximize distance. And really the trick on that, on these designs, is our power core technology. And that is a weight structure that's built into the driver that's forward and low. And as if you remember with our rad drivers, we're not just putting it all forward and low. We also have a back weight and we have some structure there. So we're trying to maximize the moment of inertia, or in another world, the radius of gyration of the CG, because we want to maximize forgiveness. We want to maximize performance. We're all about the same challenges every year. Every time we get a briefing on the new product a couple years in advance, the product marketing team comes down and says it needs to go longer and straighter than the last one. It's like, okay, yes, we know that every year. That's the goal. So you're always
so bossy, Tom.
Yeah,
so bossy.
You're always pushing at the same challenges. How can you get the CG in the right spot for the player intended? How can you maximize the inertia? How can you build in the great sound and feel? So with that and the power core in the front, you see the benefit and improvement over last year's product. But we know that 0 CGNA with high inertia is what we call the unicorn. And that's something that hasn't been done. With the original LTD, we were at 0 CGNA, but the inertia was 46 to 4,700. Now we're close to 5,200s. So that's a big benefit overall. You got more forgiveness on those misses, because we know everybody wants everything. They want distance and forgiveness.
Yeah, this is extremely forgiving too. So for anyone who does mishit the ball, but is just looking for like a driver that'll go very straight, doesn't have draw bias built into it or fade bias, which we'll get into in these other drivers, this one should be super. The only question I have is the one that I can't really test without a robot, and I'm working on that piece too, but ball speed. You getting really good ball speeds on this relative to previous models?
Yeah, the idea here is
you have a much more forgiving driver.
Right, can we bump it up a little bit? So one of the tricks we did with this driver, and internally we called this a distance driver. We didn't call it a forgiveness driver. We called it a distance driver because everybody wants distance first, then they want the forgiveness as well. So the goal was, how do we improve on last year's versions, which was the RAD XB, and XB stood for back weight with the extreme weighting. This one, the CG is slightly forward. So the trick here is, usually when you move the CG forward, you lose inertia. But our power core allows us to enable us to keep all that inertia and ball speed retention while moving the CG a little forward. So with this driver, you're going to see the combination of great launch angle, lower spin, and a little bit more speed, which you get from a more forward CG. So all in all, we should expect a little bit more that we had last year with XB.
And this looks really nice too. And maybe a follow-up question on the crown. That looks a little bit different in design too. You used to have the more wraparound design of the face going up onto the crown. Looks like you've stopped doing that a little bit shorter, closer to where I'm pointing here. Was there a reason for that, or is that helping you in any way with the design?
Yeah, I mean, one of the goals on these structures is to really maximize the ability to move weight around, so that's where you can get to a 0 CGNA. And by moving that forward, that joint a little bit forward, you're able to save some titanium weight and replace it with carbon fiber. Therefore, you have more weight to work with in terms of lowering the CG and maximizing inertia. And especially critical when you talk about crown weight, because part of the reason why most companies don't get to 0 CGNA is the crown structure, being the carbon fiber and the structural piece around it, is usually heavier than it needs to be. So if you can maximize the amount of carbon, minimize the amount of titanium, you have more weight to work with, you can get the mass properties that you guys are measuring.
Yeah, that's an interesting concept too. So what you're describing, and I'm sure you can see this a little bit from what I'm holding up, but the carbon crown is a great idea. I'd like you to show people what that actually looks like, but adhering that onto the club is sometimes the most complicated part. You feel like you've been getting better at that over the years, of either less glue or new ways to affix that?
Yeah, that's a big challenge. It's these processes can be manual processes at times, certainly by bonding them, cleaning them up. And like, as you said, it is glue. We use bonding because it's more technical sounding than glue, but it is glue. And so, this is the carbon fiber piece, very thin. This one is just under 11 grams. So that idea is, how do you put that piece together with the crown? And I could show you the crown here a little bit. So that's the casting piece. So again, every crown has to get bonded to some surface in here. So we call this the ledge, and the ledge actually is designed to be minimum in terms of weight amount, but also got to have the maximum bonding capability. So that's a better system than what we're using. If you remember the past with the two side clamshells, it's better from a number of reasons. We can use more carbon fiber and less titanium. That's the key benefit. It's also a little bit easier to put together than the clamshell pieces, because they were going over more complex surfaces than this. So that's the top piece. And then we also have the bottom piece, right? Another very thin piece, and that fits nicely into the shape as well. So a lot easier to put together, and a lot, the idea is, hey, make that joint look great and make it more efficient structurally.
And you did. I think this is a better looking driver than last year, just because that crown piece doesn't wrap around the faces quite as much. So awesome job on that one. Let's talk about LTD Max. So this one, I think you did an awesome job on it too. This one has some adjustability. You can move the CG heelward, toeward slightly, and effectively too, by the looks of it. And you've got an MOI, when I'm putting this in the most forgiving setting, of 5367 grams per centimeter squared. It went up a couple hundred there. That's the highest one I've seen this year so far. So kudos to you there, as long as the ball speed retains what you want out of it, so it's not just short and straight. That's where I think a lot of OEMs have learned over the years. Once you get over 5,000 grams per centimeter squared, if your tech isn't really good, you have this driver that goes very straight, but it won't fly as far, and people don't enjoy that. So tell me about how you kept the ball speed high and still kept the MOI on the y-axis or across the face really high.
Yeah, again, part of it is that combination of the power core, which is front and low. This one's a little bit less power core than the other two heads, because we want to maximize the back and heel weighting. So the idea here was combine the Rad XB and the Rad XD into one driver. And so that's why we were trying to maximize the performance that way. When you get the weight in the back setting, that's a super high MOI. When you get the weight in the heel setting, it's actually about 10 yards more draw than the Rad XD was last year. So we've improved it in both directions. And part of that, you talk about the across the face moment of inertia. Essentially, when you get that back weighting, that gives you the ability, both high, low, and heel toe, to maximize that ball speed retention.
Yeah, and this one does have the best, you've moved the CG quite a bit when you put the heavier weight in the heel of the club. It's a good transfer, where centered strikes are still going to act like a slight gearing effect and like a toe hit. So this would be awesome for anyone who slices, and if you just wanted like the straightest driver, I think this is the one. Because even the CG, again, you nailed it right in the middle of the club with the standard setting on this. So nice job. So how long are the driver shafts that you're using this year? What's your stock shaft?
Yeah, we're just under 46. That's sort of the industry standard. We did take out Arcos out of clubs, so we have to report sort of an Arcos length and a non-Arcos length. But we're not at 46, but we're close to it, between 45 and a half, 45 3/4, depending on which specific model.
Yep, no, that's great. I think that's good. I mean, we find the best, and this was the importance of getting fit, I think, which you would agree to as well. The worse a golfer you are, the trend that we see through product testing is that shorter shafts, 44 and a half, 44 even. If you're a rank beginner, putting a 3-wood shaft into your driver really allows you to hit the center of the face the most often and give you some good ball speeds. But we're certainly also finding the extreme goes the other way. If you're a good player, like we'll talk about this head next, the low spin, the longer the shaft, the better your results can be, because you're already pretty skilled already, and your ball speeds and club head speeds can just max out. So getting fit for the right length shaft is just as important as the shaft itself. Would you have any kind of other tips for anybody at home watching this about how to get fit for a particular shaft?
Yeah, one of the things we know is you guys have the tools to do that. You guys are the best capable in the world to do those kinds of fittings. You got launch monitors, you got the expertise. So we really trust when people go to you at GOLFTEC, they're going to get a great fit. And so I think that's a great tool. I think the other thing, we went to the longer length, but we do offer what we call tour length in a standard configuration. So that comes with some heavier head weighting and a shorter length. Those are 44 and a half. And we found the same thing that you guys are thinking about there, is that for a lot of players, that shorter length is much more consistent in terms of contact point. And the one thing I've learned over the years, and I shared this with the group last week they were not all golfers. I said, the most important thing I've learned in 32 years of working in this industry is you want to hit the center of the face with every golf club. That's the most important thing to think about in a simple concept.
It's good advice. Write that down. But you're right. That was kind of what you led into my next question, which is that tour length driver, I think, could be tour length. Unfortunately, I think PGA Tour players like Ricky Fowler, who I think you originally designed that concept around, are switching to that because they're looking for something. They can't fix their driving issues. But for bad golfers, I'd start a lot of them with that tour length driver, and that maybe is where they live for quite a few years as a player. So kudos again for making something that might be labeled tour length, but it's really made for the masses. I think that's pretty cool what you did there. And that's how we're going to position it as well. So then I've got the LS. So maybe as we talk about this, because I'm assuming, you tell me if this is right or wrong, that a majority of your tour players are playing this head. Is that fair?
I would say right now that's what the testing is showing. We do have Jason Duffner that actually prefers the LTDx.
Okay. Oh, that's great. Yep. And I can't blame him for that. It's a seriously straight driver. I'm very compelled to try that one a little too. This one just reduces the spin the most. That's why higher ball speed players really need to control that more so than the beginners or the bad golfers. But talk about when you're designing. You talked about Jason Duffner there. Ricky Fowler, I know, was the tour length vision. Any tour players that are maybe more fun to work with than others, or how's that journey go when you're trying to design a driver for someone who plays golf for a living?
Well, they're all fun, but in different ways. I think the fun part, Rick is great. We talk to Rick a lot. And Rick is really, really great at working together with us. He's great with the styling. We obviously work with Jason, who is Jason is a bit of an equipment guy. He gravitated to our equipment even before we signed him. And he's one of those guys that would test everybody's clubs and find out what is the best. So we appreciate that. Bryson is always entertaining and many ways challenging, but also, many ways he's pushing us to get better. And that's what we love the athletes for that purpose is, if everything's great, superb. If it's not great and we got to fix something or improve something, that's our challenges. And, as I mentioned before we got started, we're here for the hard questions. We're not here for the easy ones because they're easy. We're here to solve the tough technical challenges. And Bryson is some of the toughest because he's really trying to greatly improve his distance. And he's done a super job between his swing, his body, everything he's been working on the last couple of years. I think everybody was surprised, when he said, hey, I'm going to come out and I'm going to be a lot longer. And everybody's like, oh, okay, you're already pretty long. And he says, well, I've analyzed it. And the route to success for a lot of these courses is just hitting it farther. But what he did say is he said that I don't want to lose any of my accuracy. And so that's the challenge that we've run into a little bit is there's a lot of variables involved in doing that. And one of the things that's kind of simple math is, if Bryson's hitting at 320 and other players hitting at 270, that's a 50-yard difference. He's got to be 20% straighter to keep it in the fairway. So his angles, instead of plus or minus 5 degrees, he's got to be plus or minus 4. So, and that's it, assuming a straight fairway. But, that's the challenge we're up against. And it hasn't been solved yet.
That geometry of a triangle, that's just the world's problem right there. So you got this one, just to show some context, I've got the Max here in my right hand and then your LS on the other. So adjustability is built into that, but you're almost 1,000 grams per centimeter squared lower on the MOI of the LS relative to the Max, which isn't bad. It's just starting to get really interesting. And the LS is the driver that I'm going to choose to play this year for sure. But you've lowered the MOI a lot, which leads me to believe that the center of gravity on the Z-axis is pretty close to the face. That sound fair?
Very much.
This is going to be a rocket launcher. This will, if you can find the right launch and spin, this will be by far the longest driver that you've got, and maybe out of all of them, based on the design and how you've positioned that CG, I think is great. And another piece into this one is that this one should be really compelling for anyone who overdraws the ball. You have the ability to move the CG quite a bit towards the toe of the club, so it is giving you the shot to take advantage of the gear effect and slightly getting little heel hits as you strike these shots. So I'm excited about this one. Is this the one that you're most excited about?
Well, I'm excited about all of them. It's like we had 3 kids, and you can't really not be excited about any of them. It's always a little bit of a guess of what the mix is going to be. And we have some historical data from past products, and the retailers give us some guesses on mix. But that's always a challenge. When you're making clubs, you have to actually know how many you're going to make. So you got to say, hey, this one's going to be 20%, this one's going to be 40, and this one's going to be whatever, the other 40. So, that's the challenge for us a little bit. We're still kind of in that phases now where people are just testing them, experimenting with them. We think they're all great drivers. I think the LS for us is, as we talked about a little bit, it's a spin killer, and that goal was something that we heard a few years back from the retailers. We actually started doing this with the F9 driver. And they said, hey, when you get a strong player who needs less spin, they need less spin. And there's almost nothing, you can't almost go too low a spin. So that's like, okay, we know where too low a spin could be. But when you start talking about guys like Bryson and Kyle Berkshire, you're like, okay, yeah, I get it. You can really make a really tough hitting driver that has no spin. And these guys will still spin it at 2,500, so, those are some challenges we have, but the player looking for that kind of performance and typically, again, Ricky Fowler is in that category, a number of tour players, better players. This one is pushing the envelope, and, to get that, typically, as you move CG forward, you're going to lower the MOI, but these are the players who typically are hitting it on center much more often than they are mishitting it. So, the MOI loss doesn't really hurt you. And, when you look at the sort of the infinity circle on there, that's sort of what you talk about. That's about a 15 millimeter circle roughly. And so if you're inside that circle, the MOI isn't going to be a huge performance benefit because, you're pretty tight to the center. So, and most times, even with Bryson swinging, close to 140 miles an hour and Kyle swinging faster than that, when we get them in here and we are measuring center locations, they're inside the circle almost all the time. Now, occasionally, certainly they'll have a few outside that, but the MOI doesn't hurt you as much because they're looking for that spin killing performance.
Yeah, no, I think it's awesome what you did here, and I can see what you're describing with that circle too. So, if there was a hypothetical question for you, so if money really wasn't an object, time wasn't really an object to be concerned about. What might be a couple things you'd really like to explore in driver design that you just haven't had the chance to yet?
Oh, that's a good question. I think part of the fun of what we continue to experiment with is part of what is in that LS driver's aerodynamics. That's also an aerodynamic shape, and that's something that we actually use that shape to prototype in a rad head last year that they used at the long drive championships. As you know, Kyle won and Bryson came in 6th. So that was pretty exciting for them. They saw increased ball speeds and club speeds over our prior model. So that's something that we feel like has been, hey, we're just tapping into that a little bit more, because it's always a balance. In the past, when you have aerodynamic shapes, the center of gravity would go up. So we're trying to maintain that low center of gravity. That's where the power core comes in really handy. You want that low and forward, especially for spin killing. So getting aerodynamics and a low forward CG has really never been done before in the industry. So you're gonna see maximized ball speed. You're gonna see more swing speed. And overall spin killing performance. So that driver is very exciting. But I can't get more excited than over that one than any of the other two. So it's always a tough challenge.
That's fine. We'll wait till we're off camera. No, then you can tell me your favorite.
Well, I can tell you which one I'm playing, because I'm typically a high spin player, so I need the LS performance. So I typically play an LS style head, and I have for
that tells me a lot about you. You're probably a pretty good player too. So how do you? A question that I haven't really gotten a good answer from on anybody else, but I'm curious how you do it. Secret shopping your competitors, so getting to know what their products are like and learning from them. Do you do that? How do you do that? What are you trying to learn from it?
Yeah, we actually go into the market and buy everybody's clubs. We usually buy 2 to 3 per loft, because what we want to do is we want to measure them all, kind of get an idea of what the range of their specifications are. We're also checking things like, hey, how long is their club length? Some companies will say 45 and a half in their catalog, and it'll actually be 46, So there's also some old club building tricks in there that, we want to keep an eye on and understand, both from if the product performs well or if it doesn't, and kind of understand that. But we also do the mass properties. We check the CTs. We'll typically take one head, put it into the air cannon for a durability assessment. We put them on the robot and test the face mapping on the robot. We do player tests. We do some usability tests, whether it's the sleeve or weights, to see how well those work, see how well they hold up. And so at the end of that, once we do the head on the air cannon, we actually cut them apart. And so we cut them apart. We assess how much does their carbon fiber weigh, how much is their weight pieces, how thick is their face, how thick is their crowns. We're looking at detail of every little spec. So we're trying to understand, part of, okay, what makes this club work? How well does it work? How is it made? There's also some assessments that we do for patent purposes. All the companies have different patents. So what you want to do is, hey, are they in their patent? Are they creating a patent? Or are they in one of our patents? So it's a pretty deep understanding that we have on what the competitors are doing, how well they're doing. We also kind of try and estimate what we think it would cost to make their head and with all the components. So it's a constant, every year when new product comes out, we're buying those products, and we buy them at retail, so we're not getting special ones. We're just getting ones that are off the shelf and trying to make a good assessment of that.
Yeah, no, it's super interesting that you do that, and I'm sure you learn a ton. Is most of it you cutting it open, or are you just breaking it apart? Are you trying to do both when you look inside of it?
Yeah, think of it when you have a bonded club, so bonded being glued. You have to put it in the oven and then try and pry the pieces off. And sometimes they come off easy and sometimes they don't, so sometimes you'll trash the carbon fiber a little bit. But in the end, we're trying to assess a bit of, hey, how are they put together? There are still some all titanium clubs out there, or all steel, obviously, in the other clubs. So we do basically put a saw to them and cut them apart. And that's part of the understanding of, hey, what materials are they making, and how are their specs derived.
Okay. Well, Tom, that's awesome. Every time we've done something like this, I usually leave with the OEMs are doing a great job. I really believe all the OEMs that we carry are making really good drivers, and I can say that quantitatively because we are measuring them to understand what it is that they've done relative to previous years. But honestly, I can say I feel like the most advancements in the product have come from your stuff out of all the OEMs that we've measured, and I'm not just making that up. I'm a huge fan of the Cobra drivers and what you made here, so should be an exciting year for you, and like I said, nice job.
Well, thanks. We appreciate that, and we've been working hard on that.
Yep. Well, thanks, Tom.